Hello students, I am Dr. Karunendra Singh from the Department of Chemistry from Basic School of Sciences, Sanskriti University, Mathura. And today I would like to present a topic, basics on spectroscopy. As you know that spectroscopy have wide applications in various fields like agriculture, medicines, material analysis and industrial materials or smart materials. In day-to-day life, it plays a wide role. We heard about the spectrum, that is the colors. In 17th century, it was a big breakthrough when Newtons used those spectrum to analyze the material. So that we discuss as in our topic, basics on spectroscopy. So my topic covers in the following subtopics like introduction of spectroscopy, the electromagnetic spectroscopy, principle of spectroscopy, spectrophotometers and their important applications. Now, what is the spectroscopy? It's important. So it can be studied the emission and absorption of light and other radiations by matter, or you can define it is the interaction of electromagnetic radiations with matter. Spectroscopy deals with the interactions with the particles like protons, electrons and ions. Early in 17th century, Newton coined the term spectrum in his book Optics. If you see on the board, there is what a prism, and when we passing a white light through the prism, what happens? There is a making of 7 different colors which arrange as per their wavelength and frequency. So if you see a white light passes through the prism or grating, it diffracted into what? 7 colors: red, orange, yellow, green, blue, indigo and violet, which having what? A different wavelengths. Now for that we have to understand that what is the electromagnetic spectrum. Electromagnetic spectrum is the arrangement of different radiations as per their wavelength and frequency, or you can say the arrangement of the light or the radiations as per the energy levels. So first we have to see the gamma rays. Gamma rays, before gamma rays there is what? The cosmic rays. So gamma rays, if you see, they are having what? The wavelength in meters 1 to 10 to power minus 14 to 1 into 10 to power minus 12, and then after there is what? The X-rays, which having a range 1 into 10 to power minus 12 meters to 1 into 10 to power minus 8 meters. After that there is what? The ultraviolet rays, and which having a range 1 into 10 to power minus 8 to 1 into 10 to power minus 4. But before that the ultra, there is what? Before the infrared radiations, there is what? A visible range. This is a range where we have to see the things, the visible range, which having started with, it actually makes what? The VIBGYOR, that is violet, indigo, blue, green, yellow and orange and red. So these basically arranges what? As per their wavelength. If you see towards the right hand side of it is what? The high energy, which having a 4 into 10 to the minus 7 in meters, and if we see the left hand side, which having a 7 into 10 to the minus 7, which having a low energy. So they are what? The arrangement of different radiations as per their wavelength and the frequency. Now the two important terms are there when we talking about the spectrum. One is what? The frequency of the radiation, and other one is what? The wavelength of the radiations. frequency represented by f or mu, f or mu. We can represent this f is at what, the mu also. So this is basically what it depends on the time period. So if you see, there is what, a wave, a wave, it is basically that tells the total number of the occurrence of the oscillation. These are basically the oscillation of the wave. How much time it takes, that tells about the frequency, and there is a formula. It is actually f equals to 1 by t, or mu equals to 1 by t. That is what the frequency. Another important thing is what, the wavelength. Wavelength is nothing but it is actually the distance between the identical points. That is, this is what, the adjacent crest. This is the crest region, crest, and this is the next one. This is called trough. So it is the distance between the identical points, the crest in the adjacent cycle of a waveform signal propagated in space along a wire. So this is basically what, the wavelength. So distance between the two consecutive crests is actually called wavelength, and this can be represented by lambda. Now we talking about, on the basis of this wavelength and frequency, we have classified the spectroscopic method on the basis of radiations. If you see a board, there are two tables, in which one side we have to write the radiations which used in the particular spectroscopy, like X-rays, which having a range of 0.01 to 110 nanometers, which belongs to what, the X-ray absorption spectroscopy. Second, if we are talking about the UV visible, maximum materials can be studied by using UV visible range, that is 180 nanometers to 780 nanometers. And what type of spectroscopy is it? It's basically what, the absorption spectroscopy. IR, if we are talking about the IR, which having a 780 nanometers to 1 millimeters of the range, that used in the infrared absorption spectroscopy. Next is what, the microwaves, which are very important in the cooking, also in industries. So they can have the range 1 gigahertz to 1000 gigahertz, and they are very important and advanced spectroscopy to study the materials. Next is what, the radio waves, which actually used in communications. They have the range of 300 gigahertz to 3 kilohertz, and this radio waves are used in nuclear magnetic resonance spectroscopy, which are more advanced spectroscopy, and that spectroscopy have very wide applications in the medical fields, like you heard about the MRIs. So MRI is having what, it is a basic of the nuclear magnetic resonance spectroscopy. Next, we talking about on the basis of the emission, absorption or scattering. So types of spectroscopy. Spectroscopy can be defined basically into two types, absorption and emissions, but another is also, that is the scattering of the light. So absorption spectroscopy is what? It is the absorption of the radiation by a matter. I just take a help of a material. Suppose we have a material. So when materials having what, they absorb what, are radiations. Radiations means we talking about the h nu. It is E equals to h nu. Electromagnetic radiations defined as E equals to h nu, and that that first told by Einstein. So E equals to h nu. When photons strikes on the matter, so what happens? The electrons of the photons moves from the lower energy state to higher energy state, or low occupied orbitals to higher occupied molecular orbitals. So when it moves, when it absorbs, what happens? It moves, and After some time it's come back. So it's actually happens what? The radiation absorbed by the matter, and they get excited. So absorption spectroscopy uses the range in which a material absorbs the electromagnetic spectrum. It provides the spectrum, and when it returns back after 10 to the minus 8 seconds, what happens? They generate a different wavelength of light. So that is basically what the absorption. If we talking about the emission spectroscopy, emission is what? When the light come back, to their state, or the electrons come back to their original state, what happens? The emitted radiations which having a different wavelength, that is called the emission spectrum. We take an example of simple example like iron. If you heat up an iron, what happens? The iron first absorb the radiations. So that is actually called absorption phenomena, because they are in the ground state. When they get excited, what happens? They retain the heat. They reflect the heat. So that is actually called the emission. If we talking about the scattering spectroscopy, scattering phenomena first suggested by Dr. C.V. Raman. He actually tells us that when we take a material, suppose we have a material in a cell. So what happens when we passing a radiation through the solution or the material? What happens? The radiation passed or absorbed by the material, but it also scattered. Is also scattered in all the directions. That first suggested by the Dr. C.V. Raman. So that is what, on the basis of this, we can say there are three types of spectroscopy. So now we talking about what exactly the emission and absorption. Here we go in a detail that what exactly it means, emission and absorption. So if you see, there are what these spectras you have see on the board. There are what three spectras. One is what you have to see the colors. You easily distinguish what the colors. So it is when there is no absorption is there. When there is no absorption, so suppose your material is 100% transmittance, the passes the radiations, you not get what the absorption. So you have what the continuation of the lights, different colors. So that is what the continuous spectrum. So that means, or secondly, if we talking about when the light get absorbed, what happens? You get the bands. This black. If you see if you see this black bands, we use another color. So if you see these lines in the band, black lines, that actually tell us about the absorption. This tell us about the absorption of the radiation. So absorption of radiations means we talking about an atom or molecules get excited. It absorbs a certain energy in the electromagnetic radiations. Therefore, that wavelength will be absent in the recorded absorption spectrum. So what happens? So that wavelength actually get absorbed by the material. So you get the black strips within the spectrum. So this type of band form is called the absorption band. While if we talking about the emission when they emits, so when the species come back to the ground state. So earlier we talked about that this is suppose the energy. So it is the energy in the ground state, and here what the excited state. E1 is what the excited state, E0 is the ground state. So when suppose the electron is in the ground state, and when the photon strikes or the energy strikes on the electron, so this electrons moves through the higher energy state. So this is actually called the absorption. So the striking of the electrons, the energy strikes on with the electrons, then it moves to the higher energy state. That is called the excitation. This is actually the excitation. Why it is excitation? Because they absorbs some amount of the energy. That is called excitation. And when they come back their original state, so what happens? That is actually the emission. That is called the emission. It is called the emission. So emission basically what? If you see a band, so there is what? A complete black of the spectra, completely black of the spectra, and the colored strips are there. which actually tell us about the emission of those wavelength of radiations. So when the species come back to the ground state from the excited state, the absorbed radiation is emitted and it actually recorded in the type of colored strip that is called the emission spectra. Now comes to what exactly the principle. So spectroscopy having what based on some principle that is called the absorption. I'm talking about the atomic spectroscopy. So we talking about the absorption spectroscopy is governed by some laws, two laws actually behind the absorptions. So what are those basically? So two laws, Lambert's and Beer's law. What Lambert's law said? Lambert's actually said that when we take a solution, I just take another color, green. So if you see cuvette is there, we have to take a cuvette is a sample holder actually. So we have to take a sample. So Lambert said when you passing radiation, not all radiations, it is a specific type of radiation that is called monochromatic. That means a specific wavelength of radiations you have passing through the solution. What happens? The radiation actually, when it gets transmitted, what happens? The sum of the intensity of the radiation decreases. Why it decreases? Because when they passes through the solution, it travels some path. So that thickness of the path is actually it is proportional to what the wavelength, the intensity of radiation. So what happens? So it tells that when a monochromatic light passes through the solution, it decreases in the intensity of radiations. Why? Because it depends on the thickness of the material. So we have to represent it L or X we have to take. So this is what the thickness of the material. So the radiation's intensity actually decreases because of the traveling that area, they covers the area. So what happens? There is a decrease in the intensity. So that is what the Lambert's. But Beer said yes, Beer actually followed the same as the Lambert's law, that yes, it is it what the thickness also? Thickness is responsible to decrease in intensity, but it is also the concentration of the material. If you increase the molecules within the solutions, what happens? The path length as well as what the concentration, that also decrease. That also decrease what? The intensity of the radiation. That means absorption is proportional. Lambert says absorption is proportional to what? L, that is the thickness of the material. While Beer said the absorption is proportional to concentration. That is the concentration. If you more the concentration the solution, what happens? There is a decrease in what? The intensity as per the ratio. So what happens? They combine both. This Lambert's and Beer's law, they combine and write what it is. Absorption is basically what? The ACL, or it is actually the absorption is proportional to the concentration of the solution and thickness of the medium. Or you can say absorption A equals to epsilon, that is absorptivity coefficient, A equals to CL. So this is basically what the absorption. If you know the concentration and length, the path length of the medium, you can easily calculate what the absorption. So this is very important law to define that how the material get absorbed. Now we're talking about the spectrophotometer. It is an instrument which we using to find out the absorbance. So if you see, there are two pictures. One is picture figure A, which having a single beam spectrophotometer, and figure B, which is what? Double beam spectrophotometer. In a single beam spectrophotometer, you have to see there are 1, 2, 3, 4, 5. 5 boxes are there. The first is what the important, so that is what the UV light. That is the UV. If we talking about the UV visible spectrophotometer, so we have the source of radiation we have to take. Like if we talk about the visible, we have to use tungsten filament, or if we talk about the UV, so we have to take what? The mercury lamp we have to take to generate what? The UV, or tungsten having what? A mercury vapors. So that we can use. So what happens? The radiations passes through the monochromator. This is very important. Monochromator is like a filter. It is a filter which actually it actually filters the required wavelength. So what wavelength we have to need to study a material, that we have to take with the help of the monochromator. Why? Because if you study that how we can find out the wavelength of a material, lambda, that is actually called lambda max, maximum wavelength. How we can calculate, that is important. So we have to, how to know? You have to take, suppose we have to take a KMnO4, potassium permanganate, KMnO4 we have to take, and we have to make a different concentrations, 5 or 6 concentrations we have to take, and we just vary the wavelength range, the wavelength of the UV. Suppose we have to find out in the UV visible range, so we have to take 200 to 800 nanometers, we have to take a UV range. So UV basically what? The 200 to 400 nanometers, this is what the UV range, and visible is what? The 400 to 780 nanometers, or 800 nanometers, you have to write 800 nanometers. So this is what the range, whatever the material is sensitive to the radiation, that we have to take. So you have to take 2 to 400, so we have to varying the wavelength with the different concentration, and find out the absorptions at different wavelengths. So this is, we get a plot, we get a graph, absorption again wavelength. So we found that there is, when absorption increases, when actually the wavelength increases, and after some time what happens? The wavelength actually get constant and then decreases as per increasing the concentration. So what happens? If you see, there is what? Maximum absorption here in this region. So we have to easily find out the lambda. Lambda means a wavelength. So that is actually called the maximum wavelength of the material. So KMnO4. So that you can know that what wavelength we have to need. Same here, what this monochromator is actually do what thing? They just, whatever the wavelength you have to require, that they can filter. It is actually a filter. So what happens? When it gets filtered, it passes through the sample is what if we talking about the UV visible, we have to make a different concentration, so it is in a liquid. But if suppose it is in a higher active material, so we have to either it is in a liquid or solid, so generally we have to take in a solid, so we have to make a pellets. So sample holder we have to take. Sample holder is what? A cuvette. It is actually made up of a material which having a 100% transmittance, like quartz, plastic, or some crystals also shows what? The 100% transmittance, or it depends on the what type of material actually need to study. So that we have to take. And then light is passes, that monochromatic light passes through the sample, and then it detected by the detector. Detects that how much of light get absorbed by the solution, and then finally it is moves towards the computer where we get the signals. So this is actually this. If you see the figure A, it is actually the single beam. Single beam photometer means you have to take a single reading. Single reading means first you have, because when you have to prepare solutions, you have to take a reference. Reference means, like suppose we have to study chlorophyll. So chlorophyll is soluble in what? The organic solvent. So we have to take a solvent. So solvent we have to take. So before taking what the samples absorption, we have to take the solvents absorption. Then we have to put the samples. So this is in a double, in a two-way we have to do. But how to do in a single way? So we have to take a double beam spectrophotometers. So double beam spectrophotometers, in a single step we get what? The absorptions. How? So same things they have, light source, the scanning monochromator which we call. Here is difference is that they having using what? The choppers. It is actually the mirrors which actually reflects. They cut down the radiations into two beams two beams of same wavelength, and one is passes through the sample cuvette. Cuvette is actually the sample holder, that we call the cuvette, and reference and the reference cell. So what happens? They just passes through, and mirror actually reflects. They are the mirror, or you can the slits basically reflects, and they detected by the detector, and finally we get what? The display in our computer. So we get what the result. So this is basically what the type of spectrophotometers. Now how it works, you just see, you compare it. So what happens is a light source, and this is what the collimator. Collimator is nothing but it is a device which narrow the beam, and then it is passing through the prism or grating is actually what? It is actually the, if you see this monochromator, it is actually the monochromator. So it basically passes a single wavelength of light, and then light splits and passes through the sample, and sample whatever the light absorbed. This is actually the cuvette. If you see a green color, this is the solutions filled in the cuvette. It is called a cuvette, which is made up of the crystals. It may be a plastic, or it may be generally we prefer the quartz. So whatever the detector detects, that how much radiations get absorbed. So this is actually the working. How the spectrophotometer works. So light passes, collimator, they just suppress the lights and focus on the prism and grating, and then they passes through a selector, wavelength selector, and then they pass it through the solution, and then they detected by the detector. If you talking about the applications, they have wide applications. If you see many fields, pharmaceutical fields, we talking about the drugs. We have to prepare the drugs, so impurities or the unknown structure of any impurity or any compound can be easily detected with the pharmaceutical. Like if we talking about the simple paracetamol. Suppose the paracetamol having what some other compounds come out. So what happens? They may not affected. So how we can find out? So this is a technique by which we can easily find out that the suspicious material or matter in the pharmaceuticals. Same here, what if we talking about the R&D, research and developments, we have using this technique for characterization. Many materials, composites we have to make, either it is a nanomaterials or metal oxides, or the composites, maybe polymeric materials, that can be studied with the help of this technique. If we talking about the materials, yes, a specific type of materials, a spatial or the fifth generation materials can be studied with the help of spectroscopy. If we talk about the forensic science, generally we talking about the crimes. Suppose some persons kill someone, and they just remain some clues like the bloods or the fingerprints. So that fingerprints or the clues can be easily identified with the help of what? The spectroscopy. Even the traces of blood, suppose come on what the clothes, that can easily identify with the help of spectroscopy. If we talking about the astronomical things, basically is using what? The spectroscopy. If you talking about our recently project Chandrayaan, that also using what? The spectroscopy, and we got some results, and found that some spectra of availability of water is found on the surface of moon. So that also what the spectroscopy. So we talking about the another application, that is what the mineralogy and gemology. As you know that the minerals are very important for our body, and we have take what the essential minerals. So that can be easily find out with the help of what? This spectroscopy. Because if we talk about the minerals, some toxic elements is responsible for what? The health issue. So that can be easily detected with the help of the spectroscopy. Like we talk about the flame photometry. Flame photometry, it basically use what? They can detect elements in a very very traces amount. So they have they same as the atomic absorption spectra they can generate of a specific minerals or the gems. So that is very crucial about the spectroscopy, that any type of materials, minerals can be studied with the help of with the spectroscopy. If we talking about the food and beverages, that is a very big industry, and food and beverages using what this technique to identify various impurities, like if suppose a food having what minerals, toxic elements is present, so that can be easily find out with the help of spectroscopy. And if suppose they have the pathogens means we talk about the microorganisms or bacteria, fungus, so that can also be find out with the help of the spectroscopy. So they have different spectroscopy we can use in food and beverages to find out these spectra, and can conclude that yes, the food or beverages having what some kind of impurities. If we talk about the beverages, especially what we talk about the liquids, so it may be, it includes what the hard drinks and soft drinks, both. So that can be very useful. The spectroscopy is very useful. If we talk about the soft drinks not having what the other impurity, the microorganisms or microbial impurities, or the metal ions, especially what those toxic metals which are easily actually dispersed with the water. So that can be easily detected with the help of what the spectroscopy. If we talking about the environmental, they have what a very wide applications. Environmental analysis, it basically what the analysis of the environmental gases. If we talk about like the generation of carbon dioxide, the generation of methane, the generation of the hydrogen sulfide. We talk about the hydrogen sulfide because hydrogen sulfide is more poisonous, and sulfur dioxide or the other gases, carbon monoxide. So that gases, the discharge of gases can easily be detected with the help of spectroscopy. If we talk about the other analytes which can affect the environment, like toxic elements. So toxic elements, so toxic minerals. Suppose the lead is there, cadmium is there, or silicates is there. If cadmium or mercury is there, so how we can find out? So what is the easiest way? Because if we suppose to go analyze those samples in a laboratory, it takes time, it is a time consuming. But if we talk about the spectroscopy, it is a very less time, it takes a very less time to give us about the exact concentration of those impurities in a few minutes. So that is very important of the spectroscopy. Earlier we just take an example, the Bhopal gas tragedy, where the gas leak out, methyl isocyanate gas leak out, but they cannot sense, earlier it cannot sense by the peoples, because they think because they have the same efferences like the ammonia. So it's actually irritating the eyes, but nobody knows it is actually the killing gas, that is the methyl isocyanate. So if you can know, if you have this technique spectroscopy, then you can easily compare, or you can find out that what type of analyte, what type of impurities are present in our sample. So this is what another thing is what in a human detection, pharmaceutical again take because they have a very wide applications in health sector also. So like the MRI. So if suppose you have a problem in a body, so that problems can be easily detected at a very small scale by the help of these spectroscopy. So special type of spectroscopies are there for different types of the analytes, or as per the requirements. So this is all about what the spectroscopy. Now these are what the references which I have, the materials which I have collected from the sources. So this is first is Busse MM Brief History of Spectroscopy. It is basically the title of the paper from where we have to take, and this is published in Access Science in 2007. Next is what the Duckett's Foundation of Spectroscopy. It is published in the Oxford Press in year 2000. Another is what the Fundamentals and Techniques of Biophysics by Molecular Biology and Molecular Biology by Pranav. It is in 2018 by the Pathfinder publications. And lastly is what the Khalafin and Izin von Hozkers in the explanatory atmospheric sodium revealed by orbital motions, astronomy and astrophysics in 2017. So that's all about the basics of the spectroscopy, and thank you.